Right, so we're in 3.1 and last time we just looked at some general graphs, and now we're going to really get into the XY coordinate plane. So it's the coordinate plane, sometimes called the Cartesian plane for Rene Descartes. You can read a little bit about that. But what we want to remember, just a lot of the real basics here. So we have our x is our horizontal axis, the y is the vertical axis. We want to remember our quadrants get numbered in the upper right hand corner as quadrant 1, and then we go counterclockwise, so 1, 2, 3, 4. Tend to use Roman numerals, but of course you wouldn't have to. And let's see what else. We want to know that the point 0, 0, that's what we refer to as the origin. So whenever we are plotting points, we always kind of start from right there in the origin, that starting location. So that's our origin. And then just the basics of plotting points, of course, is key for what we're going to be working on. So we have XY ordered pairs. The X number tells you where to go, how far to go, right or left, again, from the origin. And the Y number tells you how far to go up or down. And then that's kind of your end points. So a couple real quickies here. Let's plot a couple of points. So for point A here, we're going to go left 3, and an improper fraction I would need to change to a mixed number. So 13 halves, oops, geez, 2 goes into 13 6 times evenly. That would be 12 with 1 left over, so 6.5. So from the origin, we would go to the left 3 and then up 6.5. So that would put us right there. I'll label that. There's my point A. Let's take a look at point B. So point B, I don't go right or left at all. That's the 0. I'm just going to go down, and as a mixed number, 3 goes into 7 twice. That would be 6 with 1 left over, so 2 1/3. So not right or left at all, just down 2 1/3. So that would be our point B. All right, so those are just a couple of the real basic foundations we should remember for working with the coordinate plane. So our next objective, we want to look at how to determine if a particular ordered pair is a solution to an equation. So in those situations, what we're going to do is the mechanics of essentially evaluating expressions. We're going to sub those values in, and then basically just see if we get a true statement. So let's say I have y equals x squared minus 4x minus 3, and I am testing to see if the ordered pair negative 2, 9 is a solution to that equation. So that means my x coordinate is the negative 2, and my y coordinate is the 9. So be careful. Every once in a while students rush in. Oops. I wrote 9. I meant to write y. There we go. So every once in a while students just get in a hurry, and like the first variable they see, they put in the first number. Be careful, the first variable here is y, so that is the 9 that we are subbing in. Now remember, when you substitute in algebra, it's always in implied parentheses here. So whatever the x is, that entire x is being squared. So that's important. It tells me that the negative in this case is included in the squaring. So as we do our simplifying here, of course, already simplified on the left, negative 2 quantity squared, that is negative 2 times negative 2, which is the positive 4. And then the 4 plus the 8, of course, is the 12. And 12 minus 3 is 9. So I get a true statement. 9 is equal to 9. So I'm just going to say yes, negative 2, 9 is a solution to that given equation. All right, let's look at another example. So number 2. Suppose we had 5x minus 3y minus 10 equals 0. And let's say we'll do a couple of them. So for part A, let's throw in a little fraction, negative 1/5, 3. All right, so again, let's say this is my x, not let's say, that is my x, and then the y is the 3. And so we are going to be subbing in for x and for y, and then the whole idea is going to be to see if we get a true statement. So in for x is the negative 1/5, and in for the y is the 3. So order of operations in that first term, 5 times negative 1/5, if you want, think of that as 5 over 1, but the 5 over 5 is just a factor of 1, but there is still a negative there. So negative 1 minus 9 minus 10. And quick glance, it almost kind of seems like it's going to work out, but as I go from left to right, I'm adding up 3 negatives. This is negative 10 minus 10. And that's not going to be 0. That's negative 20. And negative 20 is not equal to 10. So this means no. This ordered pair, negative 1/5, 3, this one is not a solution to this equation. Okay, so this is the main idea. Okay, this is what we're doing here. Let's look at another one. So part B, this time let's think about for ourselves, let's come up with a pair. So let's come up with an ordered pair that is a solution. All right, well, there's a lot of things we could do here, and we're kind of building towards something, but a lot of times if I'm doing this in class and I had just done the last example, I would have students that would be like, well, wait a second. They would kind of just look at the last example that we did. So based on the last example, that one seemed like it was pretty close. Like if I could have gotten to a maybe a 10 minus 10, then that would have worked and that would have been 0. So in order to get to a 10 minus 10, I would have wanted both the 1 and the 9 to be positive. And in order for that to have happened, when we think about the numbers that we have control of that we're subbing in, well, I want to keep the first term positive, so maybe I would just multiply by positive 1/5 there. But I'd want to make the second term positive, so I'd have to multiply by another negative. Okay, so one ordered pair that would work would be that one right there, the ordered pair of positive 1/5 and a minus 3. Hey, but there would be others. I mean, there'd be lots of other things. Okay, so sometimes, so maybe that's one approach. Maybe a more, let's say, intuitive example that I might get from students might be just to look at the fact that if they had 5 times, so this is kind of what we're looking at here, and we're trying to get this to equal 0, they might look at it and be like, well, let's just make it 10, and then I'll just make that second term 0. So this is often, again, as I've done this example in class before, this is often an example that I might get. So this one is almost, you know, just kind of looking at it from a fresh perspective and not using what we did in the last example. So this might be another example. So as we start to delve in, and especially if we were in class and I had given students maybe 5 minutes to come up with something with a neighbor, we start to realize there's an infinite number of solutions. So there are an infinite number of possibilities here. So in a situation like this, we start to kind of realize that one approach could be this. So in general, if we're trying to generate an ordered pair that's a solution to an equation, so let's look at a different equation as we're talking through these steps. So let's say I had y equals negative 2/5 x plus 2. And I could pick any x I want or any y I want, and I can solve it for the other value. So I'm going to do that here. I'm going to kind of start this problem, but just so you can kind of see what happens. So let's say this time I kind of write these out in a table form. So table is just the same thing as an ordered pair. So let's just say I randomly pick 10, and I want us to figure out what the y coordinate is, and then suppose I pick -4 for y. I could have picked any number, but I just happen to have picked those two. All right, so let's take a look at the first one. So if I plug in 10 for x, as long as I have a value for one of those variables, I'll be able to solve. So let's think of this 10 as a 10 over 1, and then you can just think of that as -20 divided by 5, which is -4, or if you prefer, this is where you can do some of that cross-canceling or cross-reducing first. Either way, you'd have -4 plus 2, and so what we get is that y is equal to -2. So that would be the missing value that we just filled in and determined, and this is really now telling me that's the ordered pair 10, -2. All right, let's look at the second one. So now let's suppose we subbed in -4 for y. So this time we don't have the x coordinate, we have the y coordinates. So the y coordinate's -4 equals -2/5 x is what I'm going to try to solve for, plus 2. So probably the first thing we do is just get our plain numbers together on the left. Let's just go ahead and subtract the 2. So -6 equals this -2/5 x. And then I could, in one step, remember how we do this, if you're down to this very last step like we have here, so if you're down to just a variable times a fraction times a variable, you could do it in two steps if you wanted to. You could multiply both sides by 5 first, and what would that do? That would reduce the 5. And then the second step, you could divide then by, maybe that -2, and that would end up reducing the -2's. But in essence, what this means is the one-step approach is that you're multiplying both sides by the reciprocal. So you're multiplying both sides by -5/2. So now we end up with x equaling -30 over -2, which is +15. So remember, when you're multiplying fractions, it is always fine to just multiply numerators, multiply denominators, and reduce. So on this one, x comes out to be 15. So what that meant is that back up here in my table, another ordered pair is the ordered pair 15, -4. So these are, it's written in table form, but those are two ordered pairs that satisfy the equation. So it really doesn't matter what I pick. We can pick anything we want for x and solve it for y, or vice versa. Sometimes one might be easier than the other. If you notice in this example we just did, the equation that was given was solved for y already, and so that made it a little easier to sub in the x number and then figure out what the y was going to be. So let's look at just maybe one more example in that. So number 2, let's say we have one that isn't necessarily solved for x or y. So just 3x minus 2y equals 4. And this time I'm just going to have us do 1 here. So suppose I have a 0 that I'm subbing in for y, and I'm being asked to find the x. So just kind of keep in mind, this is the exact same thing as the ordered pair. All right, so I'm looking at my equation here, so I would have 3x minus 2 times 0 for y. Later we're going to do more with these. When you sub in zeros on a graph, you're getting something called an intercept. So subbing in a 0 can sometimes be nice because those whole terms just drop out. Like in this case, we just get 3x equals 4. And then, of course, my last step, I would divide both sides by 3. And so I would end up with x equaling 4/3, which is just fine like it is. If I was going to graph it on a coordinate plane, I might be inclined to think of it as 1 1/3, but we can certainly just leave it as 4/3 like that. So again, it doesn't matter, I happen to have given us some numbers, but to find ordered pairs that are solutions to equations, we can pick any x we want and sub it in and solve for y and vice versa. So when we come back next time, we'll wrap up with one little application problem.